Okay, so here we have a different problem. In this case, I want to remind you that the way I want you to use these videos is for you to do the exercise, do the problem yourself, and after maybe go to the end part of this video, verify your results. If those are the same, you don't need to do anything else. If you have different results than mine, then watch the whole video and see maybe what were your mistakes. So you should probably pause it right now or look at the description that you have the whole problem there again. Let me read that. A grade G1 of 4% intersects grade G2 of negative 0.50% at a vertex whose station and elevation are 257 plus 17.65 and 4,820.14 feet, respectively. An equal tangent parabolic curve of 1,000 feet long has been selected to join the two tangents. Compute the station and elevation of the first full station inside the curve. So, as always, we're going to try to do first the drawing. So let's draw this out. We have a G1, okay? We have a G1, a positive 4%. We have a G2 of negative 3.50%. Great. That's the first two pieces of information that I got there. Now it's telling me that the vertex here, this point, and that point we'll call the station of the PI. The station of PI, the vertex of those two grades, it's gonna be 257 plus 17.65. Let me fix this a little bit here. That will be the station of the PI. And then the elevation of PI, let's put, no PI, sorry, PBI, vertical curves. And the elevation of PBI will be the 4,820.14 feet. What else is given us? So we continue reading that problem. We see that we have an equal tangent parabolic curve of 1,000 feet long. That means that, as always in this class, just in case, CE 3302, that full length of the highway, of the curve, is going to be 1,000 feet. I'm going to do it like that now. 1,000 feet, but because it's an equal tangent parabolic curve, it means that half the curve is from PBI to PVC, and obviously the opposite is also true. So here you will have the PVC, and here you will have the PBT, right? Now, the question they're asking us is for us to compute the station and elevation of the first full station. So to do that, the first step will be to find the station of the PVC. So let's find the station of the PVC. So the station of the PVC, using the formula that is not really a formula, is the station of PBI minus half the length of the curve, because this is an equal tangent parabolic curve. So the station of PBI, we know that that's 257 plus 17.65. Again, I always do my station math with like in feet, not really on stations. Our length of curve is 1,000 over 2. That's going to be 500, of course. And let's do the math over here. So what's that? Calculate. So this is gonna be something like, I can do all this here. It's 500 again. So that will be 252 plus 17.65. Okay. So that will be the station of the PVC. That is not the question they are asking, but I need that to be able to get to the answer. Now, compute the station and elevation of the first full station inside the curve. You remember, full stations are those that end up with plus 0, 0 when we are in feet. So the first full station, if PVC, if the station of PVC is station 252 plus 17.65, what would be the first full station inside the curve? So if we're moving in this direction inside the curve, what will be the first full station? Hopefully, it's relatively clear that the first full station inside the curve is going to be 253 plus 0, 0. It's going to be the first full station inside the curve. Now, that's half the answer. The other answer that we need is the elevation of that first full station. I'm going to write the first full station over here on top so I can have more space to work that out. But this will be the first full station. Let's go like that for now. 253 plus 0, 0. Let me erase some things here. And now the question is, what is the elevation of that first full station? To get there, I'm gonna need to use the formula that is relatively long. The formula says that elevation equals the elevation of PVC plus G1x plus R over 2 x squared. And let's start with the things that we need. I want the elevation, in this case of the first full station. Let me put some name here. That will be the 253 plus 0, 0. That's what I want. I need the elevation of PVC. I don't have immediately available the elevation of PVC, but I can calculate that. So let's do that. So the elevation of PVC is gonna be the elevation of PVI minus G1 L over 2. Again, G1 is that slope, L over 2 is half the curve. It's the 500 feet that we have actually here. So good, let's calculate that. YPVI 4820.14 minus G1 0.04. It's a positive, but I have the minus in the formula. Times 1,000 over 2, that's 500, but let's put it that way. And let's calculate that. So 4820.14 minus 0.04 times 500. Okay. So that there that should be 4,800.14 feet. So that's the elevation of PVC. I'm gonna put that on the corner here again because I'm gonna need the space later. Y PVC equals 4,800.14 feet. We just calculated that. Great. So I already know Y PVC. Great. I know G1. G1 is 0.04, positive 0.04. X. What is X? So X is the distance from PVC to the point that I care about. So the point that I care about is at station 253 plus 00. So let's do that. So I want to calculate X. I am at station 253 plus 00, but I'm going to use feet now because I'm dealing really with the distances in feet. And minus the station of the PVC. So in essence, I change it back to feet, 252, 17.65. And let's calculate X then. So X in this case, 253.00 minus 252, 17.65. That would be 82.35 feet. Let's put X over here. And that would be 82.35 feet. So we just calculated the distance between the PVC and the point that we care about right now, that's the station of 253 plus 00. So we have both X's. We now need to calculate R. And R follows a formula. Let me see if I see a formula over here. R follows a formula that is G2 minus G1 over L. So G2, that's going to be negative 0.035 minus G1 is positive, so minus 0.04 divided by 1,000. Let's calculate that. So that will be negative 0.035 minus 0.04. All of that divided by 1,000. That's gonna give me R negative 7.5 times the minus 5. Okay, so I have R now. So I have Y PVC, I have G1, I have X, I have R, and I have X. So I have everything I need to apply this formula. I'm not gonna change that formula there right now because I am lacking space. But know that I'm using the values that we have here. Y PVC, I have G1. Again, I will use it as 0.04, not 4%, but if I have that G1. I have the X that is 82.35, and I have R that is negative 7.5 times 10 to the negative 5. So let's calculate all of that and let's see what we get. So if we calculate all of that, we're gonna get 4,803.17 feet. That will be the elevation at the first full station inside the curve. That was 253 plus 00. It's good to check those numbers, and those numbers make a lot of sense. It's a little bit higher than the PVC. It's not too higher than PVI, so that number kind of makes sense. So I'll see you later, guys. Hope this serves you well.